So we are discussing the properties of solution. Okay, what is solution? Solution is a homogeneous mixture of two or more pure substances. In a solution, the solute is dispersed uniformly throughout the solvent. Okay, solution, the intermolecular force between solute and solid particles must be strong enough to compete with those between solute particles and those between solvent particles. Okay, you can see here diagram how does solution form when solvent pulls solute particles apart and surrounds, okay, or solvate them. Okay, you can see here in diagram solute here. Okay, this is like solvent pulls the solute particles apart. Okay, how does the solution form? If an ionic salt is soluble in water, it is because the ion dipole interaction are strong enough to overcome the lattice energy of crystal lattice of ionic compound NaCl. Okay, NaCl. Okay, ionic compound. It has salt crystal lattice energy. Okay, ion dipole interactions are strong enough to overcome the lattice energy of NaCl. That's why ionic salt is soluble in water. Energy change also takes place in water. Separation of solute molecules is endothermic. Separation of solvent molecules is endothermic, and formation of solute-solvent interaction is exothermic. Okay, we will find the enthalpy of solution by adding all these heat changes. Okay, the process solution formation can be either endothermic or exothermic. Okay, the enthalpy change of the overall process depend on delta H for each of these steps. Like why and do endothermic process? Because it occurs because when we provide energy from outside the system, the process tends to occur spontaneously. Things do not tend to occur spontaneously without outside intervention unless the energy of the system is lowered. When the system energy is lowered, the spontaneous things will happen. Yeah, we know that like in some processes like dissolution of NH4 NH3 in water, heat is observed, not released. You can see here in the diagram, you can clearly see net is endothermic process. Heat is observed, not released. You can see. Okay, solution is this. This is the net enthalpy change. Okay, enthalpy is part of the picture. You can see here when there is like some disorderedness or randomness, like you can say entropy, increase in entropy, the system tends to lower the energy. Okay, the energy of the system becomes lower, and the you can say solution is formed. You can see here right here, enthalpy may increase the overall energy of the system. Overall system energy may increase. You can see the overall energy of the system can still decrease if the system becomes disordered. Enthalpy may increase, but the overall energy of the system decreases if the system becomes disordered or some randomness occurs. Okay, like you can see that if the substance disappears during the experiment, it doesn't mean the substance is dissolved. You can't say that the result we have gotten the result. It is not like that. We have to wait some time before we can answer that the substance disappears. Okay, the substance disappears when it contacts it, but it doesn't mean that the substance is dissolved. It takes some time, and sometimes substance doesn't dissolve. Okay, dissolution is a physical change. You can get back the original solute by evaporating the solvent. If you can't get it back, it means the substance didn't dissolve, it reacted. Okay, types of solution: saturated solution, like solvent holds as much solute as is possible at the temperature. Types of solution: unsaturated, less than the maximum amount of solute for that temperature, it is dissolved in the solvent. Supersaturated solvent holds more solute that is normally possible at a temperature. This is unstable condition. It results in crystallization. Okay, solubility, saturation, and supersaturation. You can say below saturation, you can say that more solute can be dissolved. If we will add more solute, it still dissolved because it is before saturation, below the saturation point. But at a saturation point, the solvent is holding maximum amount of solute required at the temperature to dissolve. Okay, but if we add more solute, it will precipitate, and more solute will settle down. Okay, what is solubility? Solubility often measured in grams of solute per 100 milliliters of solvent. Beyond saturation, what will happen? Solvent is already holding more solute than it can be able to dissolve at that temperature. This situation is unstable, and when if we add more solute to the solution, it will after it will cause, like, it is, we can say, beyond saturation point. After saturation, if we add more solute, it will crystallize out. Okay, it will become in crystallized form. Factors affecting, okay, like we can say that chemists use like again this, like dissolve, like polar substance dissolve in polar substance solvents, and non-polar substances dissolve in non-polar solvents. Okay, like you can say polar substances dissolve in water, and non-polar substances like dissolve in organic solvents. Okay, like alcohols. The more similar the intermolecular reaction, the more likely one substance is to be soluble in another. Glucose, which has hydrogen bonding, is very soluble in water, while cyclohexene, which has only dispersion forces, is not. Okay. Okay. Gases in solution. The solubility of gases increases as with increasing mass, as attraction between the gas and solid molecule is mainly dispersion forces. Large molecules have strong dispersion forces, and that is why when they dissolve in water, they dispersed. Okay. That is one of the characteristics of water. Effects of pressure. The solubility of solids and liquid does not affected by pressure, but the solubility of gas is affected by pressure. Gases in solution. The solubility of gas in a liquid is directly proportional to its pressure. Okay, gas in a liquid, here you can see this is Henry's law. Solubility is directly proportional to partial pressure of the gas in a liquid above the liquid. Okay, there are some questions here related to Henry's law. Okay, like this is, you can just overview. Okay, temperature, effective temperature. The solubility of solutes in liquid solvent increases with increasing temperature. Okay, solubility of solutes increases when temperature is increased. Okay, the system energy is lowered, decreases. The energy of system decreases, but the entropy increases. Okay, the opposite true for gases. Carbonated soft drinks are more bubbly if stored in the refrigerator. Warm lakes have less coat to dissolve in them than cool lakes. Okay, like reverse is true for gases. Like solids and gases are opposite effects of temperature. You can see questions here. How much KCl will be able to dissolve in 100 gram of water at 50 degrees Celsius? You can use the solubility formula. Okay, what the solubility formula is? Okay, okay. You can find its formula by using its definition. Okay, I told you about. Okay, this is end of this lecture. I hope you like the lecture. Okay.